Recording is rolling. Share screen 2. All right, and here we go. All right, so double check, make sure we're up to speed here. You guys should have your, did you guys write your name in the top left corner on that card? All right, so I'll put together that same chart. Maybe by this point, sign on to this Google Classroom. And near the end of class today, I'll pull up that Google Classroom so you can see some of the materials that are already on it. You should have a curriculum syllabus that also has that code stamped on it. And you should also have that packet of papers that we'll look at later today. All right, so, wait a minute. Let me pause this recording. Pause. All right, recording is resumed. All right, so got to cover a bunch of first day stuff. So hall passes. You probably remember how the system works, but if you need a refresher or if you're from out of town and this is all completely new, you guys see the station right here? Got a laptop and a barcode scanner. Hey, that's that. It's just a photograph of that. And so the way this is working, if you need to pass somewhere, then let me know. And then there's a drop-down menu that has every single student name in it. There's like 2,300 students. Now, if you type the first letters of your last name, then it should pop up pretty fast. So you find yourself. And then there's two options of places you can go. So you're probably mostly going to click the one on the right. It says destination. And that brings up just a handful of options. There's like restroom, media center, guidance, things like that. Okay. Now, if you need to go to a specific teacher classroom, like, oh, I left my lunchbox in the last one, right? Then you choose the icon on the left. It looks like a teacher person, and then find your teacher name. Right? Okay, and then you can sign yourself up. Right? Okay, and then you'll be logged in the system as having gone to whatever destination you chose. Right? Okay. Then when you come back to the classroom, you guys have ID cards with barcodes on them. Right, so you can scan your ID card with this barcode scanner, and it should check you in. Now, I do remember last year it didn't always work, kind of some technical issues with it, but I think they patched that over the summer. So supposedly that should be fixed, so that should work now if it didn't last semester. I guess we'll find out in the next few days. But if that doesn't work, then you can still just manually sign yourself in. You have to go click, 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 and then click the back. Okay. Any questions about passes? All right. All right, evac drills. So this is the school looking from above. Now we were in building 3, which is this building right here. Right, where this classroom is pretty close to that mouse cursor, right about here. Okay. Right, so if the fire drill rings, what's the first thing we're supposed to do? Just hang out right here, right? So do nothing, just hang out right here. Right. Then they're going to come over the announcements and tell us one of a few options to do. Right? So they might say shelter in place. They do that a lot during lightning storms, and that just means we're just going to hang out in the classroom, just avoid all passes. Right? If they say lockdown, then, well, we're lucky that we have a science room with those lab tables. So we're just going to go behind those lab tables back there, right, and just wait a few minutes for that drill to be over. Right? Or they might actually send us on a fire evacuation route. And there's 2 routes that we could go. Right? So if they send us to evac site A, that's the bus loop. Right? Here's what we're going to do. So if they say go to site A, we're going to go out this door, then hang left, go all the way down at that end of the hall. Right? That will dump us out these doors right here. Right? And then evac site A is this bus loop right here. So yes, this bus loop. And they want everybody to line up in straight lines. My number is number 29, so we'll all line up right here. And they just want to keep us off this little grassy patch. So everybody's on this pavement. Okay. It's gonna be pretty crowded out there. So you guys see my name Griffin on a stick. Is this? And so I will take this out with me, and then, well, you can find that and find the class real fast. No, they might send us to evac site B, and evac site B is the football field. And on the football field, they have classes organized according to subject. So since this is a science class, we're going to this corner right here, this northwest corner. Okay? So you guys see how we're doing, right? So we would be going, coming in from this side, then just go all the way down and line up right here. Is that? Let me show you guys the map of this. Right, now this map's upside down, like south is up. Right? So on this map, we're coming in from the bottom left corner, just walk the length of the field, and then meet up over here, science. And find Griffin on the stick. You guys good there? Okay. Any questions about evat drill, something like that? All right. Aha. Start talking about this class now. So let's do just sort of a historical angle on this class. So physics, where's this class come from? Like what are the ideas that went into formulating like what eventually became physics? So we're looking at this tree. What tree is this? What's the deal with this tree? What do you think? Yeah.
The apple.
The apple. Yeah, this is the apple tree. Yeah, that Isaac Newton was looking at and sees this apple falling to the ground. Yeah, you're right. Yeah. You got it. So, actually, that house in the background, that is Isaac Newton's old house. I'll give you guys a little bit of the story. So we're talking about the 1660s. So this is, I mean, hundreds of years ago. Science had just come about like as a concept, like this idea of like, oh, I'm going to chase down this question of how something works. I might have different ideas about how it could work, or come up with a hypothesis. I'll test that hypothesis and maybe try to poke holes in it and be able to come to some conclusion, right? Like that as a concept was really new in human history at this point. Now, what most people did at this, I mean, we're talking about hundreds of years ago, most people were farmers at the time, and Isaac Newton was supposed to be too, because that's what his parents did. You normally just did whatever your parents did, and that was the skill that you learned, right? But he wasn't very good at farming. He was pretty good at math. So he was lucky enough to be able to go to college and build up his math skills. But in 1666, there was an outbreak of plague. There was this pandemic. And I mean, this is so early in modern science that there wasn't even a germ theory of illness. So nobody knew quite why people were getting sick, but they kind of figured, well, people in large groups, that tends to spread the illness. So we're going to send everybody home. So Isaac Newton was sent home from his college classes, and here he's sitting at his parents' house and right there, possibly looking out one of those windows at that there apple tree and sees this apple fall and has this epiphany about how things are working. I mean, he's really curious about how the world works, wants to figure out the laws of the universe. And he's the first person in recorded history to make the connection that the apple falling to the ground and the moon going around the earth up in the sky is all part of the same phenomenon. See, before Newton, there was this idea, well, maybe there are terrestrial laws, how things work down here on the ground, and there are celestial laws, the way things work up in the sky. And Newton is able to make the connection, say, no, actually, it's all part of the same laws. He starts writing things down. Like, here's the laws of motion. Got that poster right there, and it's kind of right. Just a handful of very small handful of laws that govern all motion in the universe. He's able to come up with the universal gravitation and inverse square law. He also needs a new branch of math to back everything up because, well, at the time, calculus didn't exist, so he had to invent that too. What is calculus, by the way? Who's taking calculus in here? Anybody take care of calculus? Maybe. How about this? You guys know algebra in a nutshell is like solving for x, solving equations, maybe some graphs, that sort of thing, right? Trigonometry in a nutshell, maybe like angles, shapes, triangles, that sort of thing, right? What is calculus like in a nutshell? It's about instantaneous rates of change, right? Or at least the first half is, and then the second half is just the reverse of the first half. So he needed to come up with all this calculus and these laws of motion to figure out how things are working in the world. So now this was just something that was his own personal interest in academic pursuit. But then, school resumes, epidemic's over, goes back to class, and everything that he had figured out and wrote down, he just kind of shuffled under the bed, and it gets lost for decades and almost lost to history, right? Until this guy's about to come by. We're up to the 1780s now. Okay. What are we looking at right there? What is that?
Comet.
It is a comet, right? And this photo was taken, I think 1980s was the last time this came by. Which comet is this?
Halley's Comet?
It is Halley's Comet. Yeah. Right. And you guys might see this when I think the next time it's going to come around is a few decades from now. So we'll be, I guess, all very old people next time. But yeah, when you guys do see this, you say, oh, yeah, actually, this is kind of the comet that lit the fire that led to physics, that led to industrialization, all the modern world. That's this one right here. So there had been this record of this comet that had been coming around every couple hundred years. And so it was predicted, and okay, since this comet's kind of due to come soon, about early 1780s. But nobody could nail down exactly why the orbits of these objects in the sky were what they were. Now, at this point in history, people did know that the sun was the center of the solar system, not the Earth. People figured that out. People also knew, and this is a wacky one they actually figured out, that if you need extremely precise measurements to figure this out. But a guy named Kepler had crunched a bunch of data by a guy named Tycho Brahe, did a bunch of astronomy, and figured out that planets and comets don't actually move in circles around the sun, but they actually move in ellipses, kind of like an oval path. Right. So they figured all that out, but nobody knew why. It's like, well, what's governing this motion? Why is this motion this? Right. So they're looking at this comet, or they're thinking about this comet that's soon to approach. Right? And one of these guys, Edmund Halley, trying to crack this problem with a bunch of other people, and he hears about this guy named Isaac Newton, eccentric math teacher over at Cambridge. So, okay, well, maybe I'll go talk to that guy, see if I can get some kind of insights to what's going on. He was talking with him, hey, he helps figure out, what's going on with this comet that everybody's trying to figure out. And Newton said, oh, yeah, I figured that out a long time ago. It's like, I figured out this inverse square law of gravitation and these laws of motion, and I backed it up with this new branch of math I invented called calculus, and boom, there you go, and that answers everything. And he was like, what? You figured this out? And we've been like sitting trying to figure this out for like years. It's been one of the biggest unanswered questions. Well, I mean, it's answered now, but you have to write this down. So it's, oh, okay, well, I guess I'll do that. So he writes it down in this book, Principia, I'll call it. That's the shortened version of that longer Latin name. That was the language of science back in the day, right? What was Latin, right? What is the language of science now? Like if you meet with a bunch of scientists, let's say particle physicists over at CERN in Switzerland, what language is everybody speaking? Are you guys thinking English? Yeah, English. That is pretty much the international language anymore. Everybody wants to know English, right? That's the language of science. Right? But back in the day, it used to be Latin. And here's his original handwriting as he's writing this book. He's doing some work on optics and refraction here, right? You guys seen, I don't know if you put a straw in a glass of water, it looks all bent, but it's not really just optics. Hey, that's what he's trying to figure out right here with this prism. Okay? So this book is the foundation of like this class physics, has most of the main points of physics in it, and also calculus, which is the math of rates of change. It's all in this book. Right? Yeah, so what is this class? This class is physics, the study of the laws of nature that govern matter and motion in the universe, which I think is a pretty good one to know, right? So hopefully you guys are figuring out about this time, maybe trying to figure out what is that you're interested in, what do you possibly want to do for the rest of your life, career path, and how do any of these classes connect to any of that, right? Which is a lot to figure out, right? That's a lot to juggle. And what I think knowing like the laws of the universe and how things get put together and how things work, that's probably a pretty good one that could carry you a long way. Now, how are you going to apply that? Well, there's 30 different students in here. You guys got 30 different life stories, maybe 30 different applications and ways you can go with this. And you won't necessarily know until like maybe years down the road and connecting the dots in retrospect. We should got a story lined up for you guys here, but hang tight on that. Let's take a look at this one. So do you guys see a bunch of little squares here? A bunch of little squares? How many squares wide is this? How many squares wide? And it's real small font. Gonna say 50, 52? Oh, 52. Okay, so each one of the squares represents what? Maybe 1 week. So an entire row represents one year, right? And okay, and then these are color coded. So you guys see this gold band right here? That's labeled high school. Ooh, and you guys, most of you guys are 11th grade. That puts you right about this box right there. And that, well, see, you're looking at a map of pretty much your entire life, right? And it goes by fast. So not too many squares on there. By next Wednesday, check off another one of these squares, one of these boxes. So what do you want to do with this? What do you want to make of your life or get out of life, or what do you want to do with it? And how's physics going to connect to any of this either? So we got next here. Yeah, hopefully you're figuring these things out. Like, what do you enjoy doing? What skills do you want to develop? You guys are at an age now where you still have a good amount of brain plasticity. So if there's still things you're interested in, skills that you want to build related to that, good opportunity time for that. Right? You guys know, like little kids, you can just like talk at them and they can just pick up a language with no effort, right? And then the older you get, you lose that brain plasticity, right? And then how is physics going to connect to any of those too? Oh, you know what? Look at this diagram real fast. And this is not like the only framework to figure out anything in life, but I think it's a pretty good one, right? So what are you good at, or could you get good at? What do you really enjoy doing? What do you love doing? What is it the world needs? And hey, what can you get paid for, right? I mean, if you could check all those boxes in a career, then you're probably sitting pretty good, right? And so how is physics going to connect to any of this, right? Now, if you are going into something like physics or engineering in college, and there's a direct connection. I mean, if you're going to be an engineer, you're going to use this class like every day for the rest of your life. It's just so foundational to so much science and engineering. But maybe you're not. Maybe you're looking at a pretty different type path. You know, like I don't know. It seems like a pretty abstract connection. Right? Well, so things to think about is one way that subjects are rolled out to you in school is everything's like seems very compartmentalized, right? Like I'm going to go to this classroom, and inside these walls I'll learn history, and inside these walls I'll learn like science, and in these walls I'll learn like math, right? It seems like very compartmentalized, right? But in the real world, everything kind of connects to everything. A lot of new like ideas and discoveries and breakthroughs that are made really have to do with like connecting things that people hadn't connected before. Like even Albert Einstein, when he came up with the general theory of relativity, he said one of his main influences that helped him develop this theory was actually just playing the violin. Right? There was this musical connection. And had he not been able to play the violin and have this incorporation of music, less likely that he would have developed the general theory of relativity, right? So it seems like a pretty abstract connection. Right? In physics, and I mean, it's like the fundamental laws of the universe that you get to learn in this class. So I think it's a really good opportunity to use now. Who knows what wide application? Right? I'm going to steal a story from a guy named Steve Jobs. You guys know Steve Jobs? So you guys have a favorite Pixar movie? Guy that founded Pixar, or anybody have an iPhone? Or even if you don't have an iPhone, you probably have a smartphone. Right? And iPhone was the first smartphone. If you have a personal computer, some of the first computers that were built were through Apple, right? All links back to this guy, Steve Jobs. Now, part of his story is Steve Jobs graduates high school. He's not really sure what he's going to do in life at the time he graduates high school. I mean, maybe he has some interests in like math and computers, but I mean, computers were like really rudimentary back in the early 1970s. So he goes to college, but even in college, he's not really sure exactly where these classes are leading or where he's going with this. What he does know is that his parents are really poor, and all their money is going to this tuition that, again, he's not really sure like what the end result of this whole thing is. So he ends up actually dropping out of college. He never actually got a college degree, but weirdly that ended up working out for him because he ended up dropping in on classes that just looked interesting, and he just like sat in the back just because he was curious to learn the content. By the way, that's a really cool thing you can do if you ever get the opportunity to go like a big university. Some of those lecture halls have hundreds of people in them. I like doing that back in the day. Just like pick one that just looked interesting. You just sit in the back, and nobody ever know you're there, and you just like learn stuff. Right now, of course, you can't get credit for anything doing it that way, but you can pick up lots of cool information. And one of the classes that he sat in on was a class called calligraphy. Who knows what is calligraphy? Yep.
Basically, really good handwriting.
Yeah, handwriting, like the art of font, right? That sort of thing, right? Okay. Now, what possible application is that going to have to anything? I mean, kind of like an artsy type class, or what are you going to do with that? Right? But he sits in there and he learns all about calligraphy just because he's curious and no other reason, right? Well, many years later, as he's putting together some of the first personal computers, one of the many problems that he and his team have to crack is how do you create a legible font on a pixelated screen? And then all those principles of font come back to him. He's, yeah, I learned all this stuff and I can actually incorporate this and we can actually create a really good, useful computer that people are going to want to buy. Takeaway from that is there's all examples of it, and you might be old enough at this point in your life where you can have some similar type examples where you picked up on like some knowledge or read some book or took some class that you weren't really sure how it was going to be useful, but in retrospect you can connect the dots right after the fact. You can say, oh, okay, I can't have done accomplished this project I just did or have done this thing had I never taken that class or had I never read that book. And like, so again, how are you going to use physics in your life? Who knows? It's possible even, I'm not going to open up this link, but it's possible that you'll even end up working a job that doesn't even exist right now, just because the world is just changing so fast. And yeah, I mean, it can't hurt to like know the laws of the universe and how to put things together and how things work. So to learn that in this class. All right, so with all that, talk about habits here. Now, you guys know what habits are, right? So routines that you get in that are really hard to break. Now, it's true that bad habits are hard to break. Like if you get into some bad routines and then you decide like in mid-October, you know what, I actually do want to be a good student. It's extremely hard to like switch over and become a good student at that point. Okay? But good habits are also really hard to break. So if you get into a routine, and how long does it take to establish habits? About 3 weeks, I've seen, about 3 weeks. So if you take like the rest of August, let's say, and just establish some really good routines, say, okay, this is the student I want to, this is the kind of student I want to be. Maybe I've been a really good student for the last few years and I just want to keep doing that. Or maybe I haven't been on top of my game, but you know what? Hey, it's a new beginning, new year. First few weeks of school in August, everybody's stress hormones are allowing us to like reset our agendas in our lives. Right? If you establish some really good routines, go home, I'm gonna maybe do some things I want to do. Maybe I have like some games I want to play or some TV shows I want to watch or some extra hobbies that aren't in my classes that involve skills I want to build. But I really want to be a good student too and get the most out of my educational opportunities. So I can knock out all my class assignments and really study this material and really have a deep understanding of the things I'm learning in my classes. If you set yourself up with a routine and really stick to that for at least through August, then you'll be pretty good as long as you just maintain that just from inertia for the rest of the year. You guys know the further we get going on in the year, I mean, you guys have lived long enough now to know that, I mean, academic work is really hard, right? I'll be working 7 days week for you guys. I know you guys be working too. And I know we're all going to walk out here in May, just like looking for the next summer. But at some point, we'll just be going just based on inertia. It's like, okay, well, I'm just going to do this just because this is what I've been doing. It's been my routine. And if you set good habits for yourself, and then one day you go home and you're like, you know what, I'm going to break this habit and I'm just going to do something silly, like just sit here and not do my homework and I'm just going to scroll through Twitter or something. I'll tell you what, that would feel weird. And you won't get very far into that before you realize, no, I really just like need to do my stuff. And just because that's what I've been doing, because that's what I decided I was going to do back on August 10th. So yeah, think about what kind of student you want to be, what you want to get out of your classes. If you've been a good student, awesome. If not so much, then hey, new beginning. It's no reason that you have to repeat bad habits if you've had bad habits in the past. And we got a new year. One of the biggest pieces of advice I can give you guys is use a planner. Now, I have an old school type planner, paper planner. Those are really good. I don't know, maybe you guys use your cell phones or something for some kind of agenda, but yeah, this will help you organize your life. I know at the end of the day, I go home, I'm totally wiped out, exhausted, and I might have 5, 6, 7 things to do. I'm not going to just like just remember those things. But if I have a planner, I have a nice, very convenient checklist. Check, get all the stuff done, and actually like accomplish things I want to accomplish in life. So yeah, if you've never used a planner before, then again, new beginnings. Try it out, and if you do try it out, then I can almost guarantee you, this is one of the best pieces of advice I've ever followed. Just use a planner. Personal interest too. So again, if there's like some hobby you have like outside your classes, go ahead and make a space and time for it in your planner. If there's a game you want to play or a TV show you want to watch, then make a space and a time for it. And then you have space and time for it, do that thing, check it off, and then you can go next thing on your list. Okay. Positive framing. Ooh, this is a good one too. So hopefully there's some classes that you definitely do enjoy just naturally. Like, oh, I really enjoy this physics class because we get to like solve all these puzzles and that's really enjoyable. Maybe something like that. And if there's something that you naturally enjoy, then that's a really good opportunity to make a lot of gains in that particular class, whatever that would be. And then you might have some classes that maybe you're less keen on, maybe less interested in. If you ever are sitting in front of an assignment and you're feeling the feeling of like, oh, I have to do this, like I'm just not enjoying this at all. Take note of that, and then think about that. Okay, well, what can I actually do about that? Because if I just stick with this feeling of like, I just like hate this and hate life, and this is just no fun at all. Well, okay, first of all, it's not helping you finish the assignment. Probably not helping you get the most that could out of that particular opportunity. It's just not going to be a fun path of plating it along the way. Okay? But if you can somehow reframe it, like, okay, well, what can I get out of this that could possibly be useful to me, or I might just be curious to know about, or what skill can I build, or just like see it in some positive light. Like math and physics problems. If math and physics is super challenging and you approach that with like a negative attitude, like it's safest, then that's not going to help you. It's not going to be a good day for anybody. But if you approach it with a mindset of like, oh, hey, these sure are a lot like Sudoku puzzles, or these are a lot like crossword puzzles, or these are actually pretty fun puzzles to solve, which I think a lot of this class is. I tell you what the laws of the universe are, and then it's like puzzles that you can solve, based on those very simple laws. Then you can get more out of the class and actually, enjoy it along the way too. Okay? So yeah, positive framing. It's a good thing to apply. And again, as a matter of metacognition, take note of that. What activities am I enjoying doing? What activities maybe could I reframe to help myself out? Okay. All right. So Dunning-Kruger effect. Some of you guys might know what this is. This is one of like many, so I should say maybe like tricks our brains play on us that it's good to know. It's good to take maybe a psychology class and kind of know how your brain works, but this is just one of many things that I think it's good to be aware of. Again, as a matter of metacognition, you can work with your brain. Okay? So what are we looking at here? There's a lot of data missing from this graph. I don't know what tests people are taking, but the basic story is here. So all the way left on this graph is like bottom quartile knowledge in some subject. So this would be like a novice to some subject. I don't know what's being tested here. It could be anything, right? This general trend works for pretty much everything, right? All human brains. So and then as you go to the right on this graph, you become closer to an expert, right? So as you take more classes on a subject, read more books on a subject, maybe read up more on the subject, right? You gain more and more knowledge, right? Now, what this green line says is it tells how people's test scores are doing in response to how much knowledge they have. You guys see there's pretty much a 1-to-1 correlation. Like the more you learn about a subject, the better you do on the test, right? There it is. It's like 1-to-1 correlation, right? So maybe no surprise there. That's how things should work, right? I should say too, let me tell you something about my AP students. I know you guys aren't AP, but it's a takeaway you can get something out of. Is the AP physics exam is like the hardest AP exam that's out there. And having seen so many students take this, I've seen this pattern over and over, that if there are students that sit down and think deeply about the material and they work really hard at it, even if they aren't naturally good at math and science, if they're like, oh man, kid, you're just like not good at math at all. I don't know if you're, even they end up passing the exam if they just like put in the time. And then students that are like cut a bunch of corners, even if they have a natural knack for math, they just end up not passing. That's what the green line says, right? Now the red and blue lines are basically the same line, so I'm just going to treat them as the same. And that has to do with perceptions, right? Now, kind of interesting, if you talk to a novice, let's say somebody that maybe knows like 2 or 3 tidbits about X subject, whatever subject this could be, right? Even though they might not score very well because they don't really know very much about it, their perception might be, oh, well, I do know like these 2 or 3 things. They will consistently overestimate their knowledge in that subject. I know I'm saying they, but maybe I should say myself or like anybody. We're talking about human brains for like any subject, right? It's this pattern over and over, right? And only by the time that you actually become an expert in that field would you underestimate your knowledge. Would your test score actually outdo how you think you do? Because by the time you become an expert in some field, at that point you understand the things that you don't know, things that could be learned, maybe the unanswered problems that nobody knows the answer to, how this field maybe connects to lots of other fields. That's like, oh, well, I don't know all these little intricate details of how this connects to this and this and this. Right? Yeah, so only at that point would you actually underestimate how much of an expert you really are. So that's one takeaway. There's another takeaway that I think is particularly applicable if you were a student. Now, this one's a little bit more nuanced, but I think you guys can follow this. Right? You guys see the slopes of each of these lines, right? Like the rise over run, right? You guys see how the green one's really steep, right? Like imagine you're walking left to right. You guys see how the green one's like a mountain? You have to walk. It's really steep. You have to take a really, you're moving up as you move to the right. But the red line, that's pretty flat, right? So as you move to the right, it's really close to this floor, which has like no slope, right? Really close, right? You guys see that? Right now, that I think is really unfortunate, and I'll tell you guys why. Because if you sit down and study some subject, could be this class, could be a different class. Let's say you put in like 2 hours of studying. Okay? How much information did you really get out of 2 hours of studying? Well, the green line tells you if you put in 2 hours, you get out 2 hours of material, right? 1 to 1. More you study, more you know. But what the red line tells you is that you can put in like 2 hours of material, and your brain doesn't necessarily immediately reward you with understanding that you've just learned 2 hours of material, right? You see how it's like basically flat right here? So you can learn a bunch of stuff, actually make real gains, and your brain doesn't necessarily reward you with like a dopamine hit or something like that, right? You see that? So it's one of these features of human brains that's good to be aware of, just as a student in general. Just know that the more you're studying, the more you spend with whatever subject, you're making gains, even if you don't immediately recognize it, right? All right, you guys see an orange card on your desk? You guys see an orange card? Right, so this is optional. You don't have to do this, but if you want to, if you write your name and some facts about yourself, and then you guys see this gray tray right here, gray tray. If you pop that in the gray tray, then I can learn some stuff about you guys. So I don't know where you're born, where you came from, what you're interested in, maybe some hobbies you do, some of your interests, maybe what you want to do in college or for a career. Yeah, just things about yourself. If you don't want to do this at all, don't worry about it. But if you do, then here in about 5 minutes, or no, we got about 9 minutes of class left. Well, right before the bell rings, got opportunity to pop that in the gray tray and good to go. Right. Recommended materials for this class. So good to have a calculator. Now that one right there, that's a picture of a TI-30X2S, which is exactly the model that I use myself. And I do have a class set, so you probably have one of these on your desk. A couple short, you might have like a slightly different scientific, but I have those. So if you want to follow along exactly with me as I'm doing some calculations, say, okay, so you punch that button and then that button and that button exactly. You want to see like exactly button for button, then that'd be a good one to have. That's my favorite model of scientific calculator for lots of reasons. That has lots of cool features, but let's get to see that throughout the year. Planner. Oh, I talked about planner already, right? If you've been in the habit of using a planner just in the past, then you know like how useful this planner is. Oh shit, this made my life like so much more efficient. I got so much more stuff done, and I was even able to do all the stuff that I wanted to do outside my classes because I was organized, right? And if you've never used a planner before, then hey, new beginnings. It's a new year. Try some new things and really try this, right? Either get a planner or maybe some makeshift planner, or maybe you have like some planner on a phone or something. Whatever you guys use. Right? Notes. Yeah, notebook to keep notes. Probably a good idea to keep notes in this class, right? One reason it's good to keep notes is that if you write things down in your handwriting, your brain is able to process and learn better than if you just listen. Okay. That's actually what I got for this next slide, this learning pyramid. Now, I should tell you guys that what you're looking at right here on the slide is not 100% scientific, but it is a really good adage that has a lot of truth in it. So I'll go and run through this. So how much information do you retain from different methods? Well, if you just sit down and listen to a lecture, like somebody just talks to you, you might remember a couple of things, but probably not very much. Right? Ooh, reading. Hey, reading. That's a little bit more active on your part, isn't it? Right. Now, okay. And then as you go down this pyramid, you guys see it, it becomes more and more and more active on your part. Maybe let's see, practice doing. We're going to do plenty of labs in this class, right? So you get up and walk around, get your hands on some materials, and talk to each other and figure out how the laws of the universe work on a very fundamental level. And then the best way that you can learn a material is actually to teach other people. I know it's true for me. I got really good at physics by that was my job in college, was tutoring physics, and yeah, just seeing a bunch of problems over and over again and having to explain it to other people. That's how you can really get good at it. So there'll be plenty of days in here. I'll have you guys in small groups. There'll be plenty of labs that we're going to do. So yeah, if you guys can help each other out, then that's actually a good way you can help yourself too. Okay. You guys see a couple of shelves up here, a bunch of demos. Right, so these are pretty fun. I'll be pulling out some of these here and there throughout the year to demonstrate different physics concepts. You can get your hands on these too. So if you have a spare minute here or there, and you get to walk over and try some of these out. Yeah, let's try this one. You guys see this color wheel? It has all these colors on it, right? What do you get when you put all the colors together? You guys thinking that right there? Ooh, look at that, right? So there's a Newton's color wheel. Isaac Newton figured that out among a bunch of other things, right? Got Newton's cradle. I showed that already. Right, so fun things there. All right, curriculum and syllabus. All right, so here's you guys. So what are we doing? We're going to start with maybe recap some basic math with you guys, like algebra, trigonometry. We're going to do some vectors, direct application of trigonometry. Okay, we'll go into like a linear projectile motion, just like displacement, velocity, acceleration. All right, then we're going to say, well, what causes that? So like if you push on something like a force, look at Newton's laws of motion, circular motion, gravitation. Put those together, get orbits. That's like the apple and the moon, and right, orbits. Right, energy, momentum, harmonic motion like pendulums. See rotational dynamics, so more rotation stuff, right? Then into so further into spring semester, thermodynamics, materials engineering, waves and sound, electromagnetic spectrum optics, relativity, electricity and DC circuits, magnetism, EM induction, and quantum mechanics. So there you go. There's the outline for this class. Okay. And then in the bottom right, you guys see that Google Classroom code. A lot of you guys have probably already signed up for that. I actually do want to show you guys what's on that Google Classroom. We do that. We find Google Classroom. Let me go to you guys. Conceptual Physics. All right, let's take a look. You guys' textbook. Actually, there's a slightly different edition I found. It's PDF that's there. You guys see these posters hanging from the ceiling? I made those last year, put them on a file. There's University of Colorado, Boulder has some interactive physics demos, so it's good to check out. Some of the pages that are on your desk already, I uploaded here. There's this one. Paul Hewitt. This is an old college teacher. He has lots of really cool, like 1-2 minute demos, and also really good personality and presentation style. So I'm going to bring up some of his videos sprinkled throughout the class, but if you want to find them, they're kind of hard to find on YouTube. They're not all on YouTube, but they are here, so you can download them. Head start there. Curriculum syllabus is here, district calendar, and then some of the stuff we're doing next week. So trigonometry and algebra review right there. Right. Right. Okay, so back to this. This is one of the pages that's on your desk. Or actually, it's part of the staple packet, isn't it? Right. So it's approximately the order that we're going through these. See some main ideas, topic by topic. What would tip off that it's that category of thinking? Some formulas that pertain to that subject. Some pretty fundamental common examples, and some graphs. We have lots of graphs in here. I should tell you guys, I did design this page with my AP students in mind. So this class is going to be a bit more fundamental, more conceptual, but this is a really good checklist, which stuff we're going to be doing. We're also going to be doing a bunch of topics that are not on this page because AP doesn't ask things about like thermo or optics, but or DC circuits anymore. So, but we'll do that too. Right. Another page in that staple packet looks like this. Every single variable and unit in this class is on this page. So, for example, you guys see R radius measured in meters. Could you measure the radius of a circle in meters? Do you think it could happen? Right. So yeah, good to become familiar with these. I won't necessarily like waste time in class writing these out on paper when you get to every new topic because here they are, right? Kind of a force measured in, well, if you're in the English units, you might say pounds, but we're going to be using metric systems, so we're going to be using newtons, right? Right, there you go. Two sides, every single variable and corresponding unit. Right, there you go. Right, so yeah, check out Google Classroom tonight and explore those materials. Okay, you guys ready for lights? From lights. Okay, got about a minute of class left. So if you happen to write some things on that orange part about yourself, then here's gray tray. You can pop that in there, and yeah, we'll call that a wrap on class.